Have you ever wondered how our solar system, with its diverse planets and moons, came into existence? Today, we're going to take you on a journey back in time to witness the birth of our solar system. We'll delve into the mysterious beginnings, from the swirling nebula that gave birth to our sun, to the formation of the planets that we call home. Imagine, if you will, a time before Earth, before Mars, before any of the planets existed. There was only a vast, seemingly infinite expanse of cold, dark space. But within this space, the seeds of a new solar system were sown. The cosmic dance of creation was set into motion, and from the chaos, a new order emerged, our solar system. We'll explore the theories and the science behind this remarkable process, uncovering the secrets of our cosmic neighborhood. So, buckle up as we embark on this cosmic journey back in time. To understand the birth of our solar system, we turn to the solar nebula theory. This theory is like a cosmic recipe describing how our solar system was cooked up from a large rotating cloud of interstellar dust and gas. Imagine a nebulous soup swirling and spinning in the vast expanse of space. This was the raw material from which our solar system was born. This cosmic cloud, known as a molecular cloud, was not just sitting idle, it was dynamic, full of motion. Within this cloud, there were areas with denser pockets of gas and dust. Over time, the force of gravity pulled these denser areas together, causing the cloud to collapse under its own weight. As the cloud collapsed, it began to spin. This is a common phenomenon in nature known as conservation of angular momentum. Think of a figure skater spinning on ice. When they pull their arms in, they spin faster. In much the same way as the cloud contracted, it spun faster and faster. This spinning motion caused the cloud to flatten out into a disc shape, like a cosmic pizza. This is what we call a solar nebula. It's a lot like the disks of gas and dust we see around young stars elsewhere in the galaxy today. Now, within this spinning nebula, something fascinating happened. The dust and gas didn't just swirl aimlessly. Instead, they began to clump together, forming larger and larger aggregates. This process is known as accretion. But what's at the center of this spinning disk? Well, the center of the nebula was the densest part, and it's here that the majority of the mass accumulated. As the material at the center became denser and denser, it also got hotter and hotter. And at the center of this spinning disk, a protostar started to form, which would eventually become our sun. So there you have it, the solar nebula theory in a nutshell. It's the story of how a humble cloud of gas and dust transformed into a spinning disk of creation, setting the stage for the birth of our sun and the planets that orbit it. Now, let's witness the dramatic birth of our sun. Our story begins with a massive cloud of gas and dust known as the solar nebula. Amidst this celestial fog, a tiny protostar began to form. This was the very seed of our sun, a fledgling star taking its first steps in the grand cosmic ballet. The protostar, like a cosmic toddler, was unstable at first. It grew by drawing in more and more matter from the surrounding nebula. As it grew, the pressure and temperature at its core increased exponentially. This was a place of unimaginable heat and pressure, a crucible where elements were forged. The growing protostar was a voracious entity. Its immense gravitational pull acted like a cosmic vacuum cleaner, drawing in the rest of the nebula's matter. This matter, predominantly hydrogen, was pulled into a swirling disk around the protostar, setting the stage for the formation of planets. But let's return to our budding sun. As it continued to grow, the pressure and temperature at its core reached a critical point. This is where the magic happened. The intense conditions ignited nuclear fusion, the process that powers every star in the universe. Hydrogen atoms began to fuse together to form helium, releasing a tremendous amount of energy in the process. This was the moment of the sun's birth. It was no longer a protostar, but a fully fledged star, radiating energy and light into the cosmos. The birth of the sun was a game changer. Its immense gravitational pull kept the rest of the nebula's matter in check, causing it to orbit around the newly formed star. This was the beginning of our solar system as we know it today. With the sun now shining, the stage was set for the formation of planets. And that, friends, is the awe-inspiring tale of our sun's birth. From a tiny protostar to a burning beacon of light and energy, its formation is a testament to the incredible forces at work in our universe. From this swirling mass of gas and dust, planets began to take shape. Now let's dive a little deeper into this fascinating process. After the birth of the Sun, the remaining matter within the solar nebula didn't just disappear. No, it had a destiny of its own. Imagine a cosmic dance, where tiny dust particles began to pirouette around each other in the vast expanse of space. Drawn together by gravity, these particles started to collide and stick together. It's a bit like building a snowman, where small snowflakes pile up and compact to form a larger structure. As more and more particles joined this celestial conga line, they began to form larger clumps, growing from mere specks of dust to boulder-sized chunks. We call these growing bodies planetesimals. These planetesimals are the very building blocks of planets, the foundation upon which our home and its celestial neighbors were built. Now imagine these planetesimals, some as large as kilometers across, hurtling through space, colliding and merging with one another. Each collision, each fusion, caused these planetesimals to grow in size, slowly but surely. In the inner solar system, close to the Sun, the heat was too intense for volatile compounds like water and methane to condense. Here, the planetesimals were made mostly of rock and metal. These materials could withstand the Sun's heat, which led to the formation of terrestrial or rocky planets like Mercury, Venus, Earth, and Mars. Farther away from the Sun, it was a different story. Here, in the cooler regions of the solar system, icy compounds could survive. Planetesimals made of ice, along with rock and metal, grew to become the gas giants like Jupiter and Saturn, and the ice giants like Uranus and Neptune. And so, through countless collisions and mergers over millions of years, the planetesimals grew and evolved. They transformed from modest cosmic pebbles into the grand planets that we see when we gaze up at the night sky. As these planetesimals continued to collide and merge, they eventually formed the planets we know today. But what about the moons and other debris in our solar system? Let's delve into the lesser-known heroes of our cosmic neighborhood. You see, moons and other celestial debris have played a significant role in shaping the solar system as we know it today. So, how did these moons come into existence? Most of them were born from the very material that formed their parent planets. Imagine a massive cloud of gas and dust swirling around in space. As this cloud collapses under its own gravity, it forms a star, and the remaining material starts to form a flat, spinning disk around it. This disk is the birthplace of planets and moons. When a planet forms, it's a rather violent affair. There's a lot of crashing and smashing, with chunks of rock and ice colliding at high speeds. Some of these collisions are so intense that they send debris flying into space. This debris, still under the gravitational influence of the parent planet, can coalesce over time, gradually forming a moon. But moons aren't the only debris in our solar system. Scattered across the vast expanses of space, we find asteroids and comets. These celestial wanderers represent the leftover building blocks that never managed to coalesce into planets. Take asteroids, for example. These are remnants from the early solar system, relics that have survived for over 4.5 billion years. They give us a glimpse into what the conditions were like when our solar system was just a baby. Comets, on the other hand, are icy bodies that come from the outer reaches of the solar system. As they approach the Sun, their ice vaporizes, creating a glowing coma and a tail that points away from the Sun. It's a spectacular sight to behold, a reminder of the dynamic and ever-changing nature of our solar system. In essence, every piece of debris, every moon, asteroid, and comet tells a part of the story of our solar system's history. They are the silent witnesses to the birth and evolution of our cosmic neighborhood. And so, from a cloud of dust and gas, our complex and beautiful solar system was born. And there we have it. A journey from the birth of our solar system to the formation of planets and moons. We started this cosmic voyage by setting the stage for our exploration of the solar system's formation. We then delved into the solar nebula theory, the leading explanation for how our solar system came into existence. Our journey took us to the dramatic birth of our Sun, born from a massive cloud of gas and dust. We explored the intriguing process by which planets, including our very own Earth, took shape. and we learnt about the formation of moons and the role of debris in sculpting our solar system. This journey has given us a deeper understanding of the celestial bodies that surround us. Remember, every star you see in the night sky represents another solar system with its own unique story of formation. Until next time, keep looking up.